Welcome to MRL. In this learning session, we'll learn the solutions of the examples of exercise 7.1 of 10th CBSE textbook. The chapter is Coordinate Geometry. Now, in exercise 7.1, the first example is to find the distance between the given coordinate points. We are given two coordinate points A23 and B41, and AB is joined. We have to find the distance AB here. So for that we can use the distance formula. Now we know that AB is equal to, by distance formula, square root of x2 minus x1 whole raised to square plus y2 minus y1 whole raised to square. So here x1 y1 are 2 3, x2 y2 are 4 1. So applying using this distance formula, substituting the values of x1 x2 y1 and y2, we go for finding out the distance AB. Now x2 minus x1 is 4 minus 2, and y1 minus y2 minus y1 is 1 minus 3. 4 minus 2 is 2 square. 1 minus 3 is minus 2 square. 2 square is 4 plus 4, that is square root of 8, and therefore it is 2 root 2. The distance AB is 2 root 2. In the same manner, we can find out the distance AB here, given the coordinates of A and B, and then in the same procedure, by using distance formula, we can find out the distance AB as we know the coordinates. Now let me just help you in solving this example. Now A is AB here and B is minus A minus. The coordinates of A are AB and coordinates of B are minus A minus B. Now the distance formula is AB is equal to square root of x2 minus x1 whole to square plus y2 minus y1 whole to square. So it is minus A minus of A whole to square, then minus b of whole raised to square, that is minus a minus a becomes minus 2a square plus minus 2b square. So it becomes 4a square here, 4b square here. That means 4 is common, taking 4 outside, a square plus b square. So square root of 4 is 2. 2 times root of a square plus b square is the distance AB there between the two coordinate points A and B. I think you can solve the second example yourself. Now let us go further. Now to find the distance between the points 0 0 and 36 15, again the same procedure, use the distance formula. So 36 minus 0 square, 15 minus 0 square, that is 36 square plus 15 square. 36 square is 1296, 15 square is 225. When we add it is 1521. Square root of 1521, as I have found out here, it is 39. Therefore the distance AB is 39 units. Now to determine the points 1, 5, 2, 3, minus 2, minus 11 are collinear. So we are given here 3 points and we have to show that they are collinear. Collinear means they lie on the same straight line. And for that the procedure is very simple. Assuming that A, B, C are collinear, then we have to show that AC is equal to AB plus BC. That means the distance AB, if I add to the distance BC, then AB plus BC must be equal to the distance AC. If I show that they are equal, then the points are collinear. So let us find out AC first. Now to find AC, I have again used the distance formula here, x2 minus x1 whole to square plus y2 minus y1 whole to square. That is substituting the values of x1, x2, y1, y2, we get root of 265. Similarly, again find out, we have found out AC here, now find out AB. Then AB will be again substituting the values of x1, x2, y1, y2, we get root of 5. Now find out BC. Now BC is equal to, again substituting the values of x1, x2, y1, y2, I have got the value as root of 112. Now substitute the values here. AC is equal to AB plus BC. We know that AB plus BC is root 5 plus root of 112, and AC is root of 265, and approximately we can find out here root of 5 is 2 point something, root of 112 is 10 point something. Now when we add, we get 12 point something, that is 12.81 here, whereas root of 265 is 16.27 approximately. Therefore we find that AB plus BC is not equal to AC. Once they are not, if the distances AB plus BC is not, if it is not equal to AC, then the 3 points are non-collinear. So please remember that. That is the easy method of finding out whether 3 points are collinear or not collinear using distance formula. Now coming to the next example, to check if 5 minus 2, 6, 4, 7 and minus 2 are the vertices of an isosceles triangle. We are given a triangle ABC. The coordinates of the vertices are A 5 minus 2, B 6 4 and C 7 minus 2. Now we have to show that the vertices are whether the vertices are of an isosceles triangle. Now for that, it's a simple thing is find the distances AB, BC and AC and find out if two sides are equal. Now I found out AB here, applying distance formula I got root 37. I have found out AC by applying distance formula I got 2. and I found out BC by applying distance formula. I got root 37, and we find that there are two sides, that is AB and BC, both are equal to the root of 37. That means two sides of this triangle are equal, therefore it is an isosceles triangle. Therefore the vertices given, that is A 5 minus 2, B 6 4 7 minus 2, are the vertices of an isosceles triangle. That is what is the proof, or that is what is how we find it out. Now the next example, ABCD are the points where four friends are seated. From the figure, the coordinates of the points are given. For example, if you look into the textbook, there are four people seated, and we just find out the coordinates of that. I have found out the coordinates of ABCD seated there, and the coordinates of A are 3 4, B is 6 7, C is 9 4, and D is 6 1. Now we have to show that whether the points where they are seated, it forms a square. And for that, what we can do is, let us draw the square first. Let us assume that ABCD is a square. A is 3 4, B is 6 1, C is 9 4, and D is 6 1. These are the coordinates of the points ABCD where the four people are seated in the class. Now to show whether it is a square or not, and confirm whether it is a square or not, first of all find AB, find BC, find CD, and find DA. All the four sides you have to find out. That means AB by applying distance formula we got 3 root 2, BC by applying distance formula we got 3 root 2, CD by applying distance formula we got 3 root 2, DA also we got 3 root 2. That means all the four sides are equal. AB, BC, CD and DA are equal, but that does not confirm it is a square. Now go to find the diagonals, that is AC and BD. Now the diagonal AC applying distance formula I got 6, and BD also I got 6. The diagonals are also equal. So therefore in a quadrilateral, if four sides are equal and the diagonals are equal, 100% it is a square. So therefore the figure ABCD, where the four students are seated, those 4 points when joined by line segments, it forms a square, and that is proved here. And I believe that you all know how to use distance formula. Okay, apply distance formula and solve this example. Now coming to the next example, name the type of quadrilateral formed by the following points. We are given a quadrilateral ABCD, and the coordinates are minus 1 minus 2 1 0, minus 1 2, and minus 3 0. So A is minus 1 minus 2, B is 1 0, C is minus 1 2, D is minus 3 0. Now find out by using distance formula, find AB, BC, CD and DA. So we have AB is equal to 2 root 2, BC is equal to 2 root 2, CD is equal to 2 root 2, and DA is also equal to 2 root 2. That means all the four sides are equal, but still it is not confirmed what type of quadrilateral it is. Therefore now find out the diagonals AC and BD. Now we find AC it is 4, and find BD it is 4. We find that the diagonals are also equal. So four sides are equal, diagonals are equal, and 100% the quadrilateral, given quadrilateral is square. Now coming to the next example, to find the point on x-axis, which is equidistant from 2 minus 5 and minus 2 9. That means we are given x-axis, and there is a point P there on the x-axis with coordinates as x and 0. That means x coordinate is x and the y coordinate is 0. Now there are 2 points A and B which are equidistant, which is equidistant from P, that is 2 minus 5 and B minus 2 9 are equidistant. Now we have to find out the x here, that is the coordinates of the point P which lie on the x-axis. That means we have to just find out the value of x, and for that let us start with knowing that PA is equal to PB. It is given to us. If PA is equal to PB but natural, PA square is also equal to PB square. So using the distance formula to find PA and PB, PA is x2 minus x1 whole square plus y2 minus y1 whole square, x3 minus x1 whole square plus y3 minus y1 whole square, and square of that, when I square on both the sides, because PA square PB square becomes square and square. So when I square it, I get 2 minus x whole square plus minus 5 whole square to minus 2 minus x whole square plus 9 square whole square. So that means now when I take the square root is removed by taking the square. So 2 minus x whole square minus 25 is equal to minus 2 minus x whole square plus 81. So simplifying this, applying A minus B whole square formula here, so we get 2 square is 4 and plus x square, then minus 4x minus then plus 25, then we have minus 2 square is 4, then we have minus x whole square plus x square and plus 81, and it is 4x here. So we have x square gets cancelled here, and 4 and minus 25. Okay, please understand here, it is 4 and minus 25, so it is not plus 25, it is minus 25. And understand here that is minus 5 square is there here, minus 5 square. Minus 5 square becomes plus 25 and not minus 25. It is wrong here. It is not minus 25. It is plus 25. It is correct. Plus 25 is correct. So plus 25 plus 4 becomes plus 29. So minus 4x plus 29 is equal to 4x plus 85. Minus 4x is equal to 85 minus 29. Minus 8x is equal to 56. X is equal to 56 by minus 8. Therefore x is equal to minus 7. So please correct this. It is not minus 25 because minus 5 square becomes plus 25. So please remember that this is plus 25 and not minus 25. Now therefore the point on the x-axis, since we have got x is equal to minus 7 here, so the coordinates of the point on the point P on the x-axis is minus 7 and 0. A very simple method using the distance formula. Now the next example is we are given P2 minus 3 and Q10y. We have given 2 points P2 minus 3 and Q10y. The distance PQ is 10. Okay, the distance between the 2 points PQ is 10 units. Now we have to find the value of y. Again, same procedure. So PQ is given as 10 units. Now PQ is equal to distance formula is root of x2 minus x1 whole square plus y2 minus y1 whole square. Now PQ I can substitute the values. Simple. 10 minus 2. And y minus of minus 3 becomes y plus 3 whole square, that is a square plus y plus 3 whole square. So PQ is equal to 64 plus y plus 3 whole square, that is 10 is equal to so much. Now squaring on both the sides, 10 square is 100, so 64 plus y plus 3 whole square. Now then we have y plus 3 whole square is equal to 100 minus 64, y plus 3 square is equal to 36, y plus 3 is equal to plus minus root of 36, taking square root on both the sides, we get y plus 3 is equal to plus minus 6. So y plus 3 is equal to 6, y plus 3 is equal to 6, therefore y is equal to 3, y plus 3 is equal to minus 6 because we have two values of y plus 3 here, so y is equal to minus 9, therefore the value of y is 3 or y is equal to minus 9. So very simple, again using distance formula. Okay, remember that. Now here in this example number 9 we are given 3 points rather, P5 minus 3, Q01 and Rx6. Now they have also said that Q01 is equidistant from P and R. We have to find the value of x. So the first thing is we have to find value of x, and also we have to find the distance PR, and also we have to find PR and also QR. Now let us draw a simple diagram here. If Q01 is a point, then P is 5 minus 3, R is x6, and Q is equidistant from PR, that means QP and QR are equal. So QP, that means PQ and QR is equal. So PQ is equal to QR, rather PQ square is equal to QR square. Therefore, applying the distance formula on both the sides and squaring them, we get x2 minus x1 whole square plus y2 minus y1 whole square, x3 minus x1 whole square plus y3 minus y1 whole square. Substituting the values here, very simple again. Here we got x2 and x1. So 5 minus 0 whole square plus minus 3 minus 1 whole square equal to x3 minus x1, that is x minus 0 whole square plus y3, that is 6 minus 1 whole square. So 5 square and minus 4 square, then this is x square, this is 5 square. So 5 square and 5 square gets cancelled. X square is equal to 4 square, x is equal to 4. Very clear, x is equal to 4. The first answer is x is equal to 4. We have got it. Now we have to find out QR and PR. QR is again the distance, this distance there. Again use the distance formula, that is we know that it is x minus 0 whole square plus 6 minus 1 whole square, but we know that x is equal to 4. So 4 minus 0 whole square plus 6 minus 1 whole square, that means 4 square plus 5 square, that is 4 square is 16, 5 square is 25, 16 plus 25 is 41. So the answer is root of 41. So QR is root of 41. Now we have to find out this distance PR. PR is again x minus 5 whole square, 6 minus of minus, this being a 6 plus 3 whole square, but we know x is equal to 4. So 4 minus 5 whole square plus 9 square minus 1 whole square plus 9 square, 1 minus 1 square is 1 and 9 square is 81, square root of 1 plus 81 is root of 82. So that is the answer for the distances QR and PR. Remember that. Now coming to the 10th example, we are given point A and B as 3, 6 and minus 3, 4. PXY is equidistant from A and B. Pxy is equidistant from A and B, that means PA is equal to PB. Now we have to establish a relation between X and Y, because there are two unknowns here, we have to establish a relation. Very simple again. Now PA is equal to PB, that means PA square is equal to PB square, or the distance formula square is equal to distance formula square. Now substitute the values here. So very simple. Substitute the values here. So 3 minus x whole to square, 6 minus y whole to square, then minus 3 minus x whole to square, and 4 minus y whole to square. Now expand it, applying the identity. 3 square is 9 plus x square, 3 to the 6 minus 6x, 6 square is 36, y square, 6 to the 12 minus 12y, then minus 3 square is 9 plus x square, then minus into minus is plus, 3 to the 6x, then 4 square is 16, then y square, and 4 to the 8 minus 8y, applying a minus b whole to square. Now simplify that. When you simplify it, a very simple method of simplification, so follow that simplification method, then we find that it is 3x plus y equal to 5, or 3x plus y minus 5 equal to 0 is the relation between the x and y. So we get here a linear equation in two variables. Okay, so that is what is the solution expected of us, and that is what is the solution we have found out. Now this is how we solve the examples of the coordinate geometry. That is the first exercise 7.1 of coordinate geometry chapter of 10th standard CBSE textbook. So please follow this. A simple thing, only one important formula has to be remembered in this, and that is the distance formula. So using the distance formula we can solve all these examples. Only we should know how to simplify. The basics of algebra, basics of arithmetic are to be understood and remembered and applied. So go through them, understand them, write down in a book for your future reference. Okay, thank you.